Good morning friends. Today in this video I will be uploading the topic trigonometric identities, its examples and exercises. And if you like this video, please subscribe, and if you want to share, please share it. We will go forward. So first we will look at all the there are mainly three identities. First we will look at the three identities first. First is sin square a plus cos square a plus cos square a equal to 1. This is the first identity. This one you can have in many subdivisions. For example, sin square a equal to 1 minus cos square a, and cos square a equal to 1 minus cos square a. These are the two subdivisions, and this is the first one, third one. Now second one identity is the 1 plus tan square a equal to sec square a. 1 equal to, subdivisions are 1 equal to sec square a minus tan square a, and tan square a we can write it as, and another is tan square a, also we can write it tan square a equal to sec square a minus 1. So these are the two subdivisions of this, and third is this. Now third identity says that 1 plus cot square a equal to cosec square a. 1 plus cot square a equal to cosec square a. So the subdivisions are cot square 1 equal to cosec square a minus cot square a. And cot square a equal to cosec square a minus 1. So these are these two subdivisions, and this is third. So basically there are only three identities which you can split into these subdivisions. That is, these are the identities. So this one you have to by heart, and these are the page number. It is in page number 190. Now we will move on to the examples. First is express the ratios cos A, tan A, sec A in terms of sin A. That means we have to express cos A, like for example cos A equal to in terms of sin A. So first we will write the given thing, cos A in terms of sin A, then tan A terms of sin A, sec A. Now sin square A, first we will use the identity and find this, because cos is included in that identity. So we will use the identity sin square A plus cos square A equal to 1. And now cos square A you have to find. So it will be, we have used the subdivision that we already saw in the before the previous slide. So it will be 1 minus sin square A. Now cos square it is, so you have to find cos A. So it will be root 1 minus sin square A. So this is how we found out what is cos A. Now tan A. Now we'll find sec A first, because sec A is just the reciprocal of cos A. We know that cos A equal to 1 by sec a. That means sec a equal to 1 by cos a. That means 1 by this we can say that 1 by root 1 minus sine square a. So we got the ck also. Now we will see how we will get tan a. Tan a is nothing but tan square a, we can keep it as, for example, tan a. Okay, then we will write tan a as one more thing, that is sin a. This is another formula for finding tan a is sin a by cos a. Sin a by cos a. Let me show you how we found this. We know that sin is nothing, tan a is nothing but opposite by adjacent. Tan a is opposite by adjacent, and sin a is nothing. And now sin a, we know that it is nothing but, now we will solve the RHS of this. We'll take this as the thing and we'll solve. This is an extra information for you, that is write it as EI, extra information. So sin a by cos a is nothing but opposite by hypotenuse, that is sin a, and cos a is nothing but adjacent by hypotenuse. Now if you bring this and cross multiply, it will be opposite by hypotenuse into hypotenuse by adjacent. Hypotenuse cancel, so what is left is opposite by adjacent. So this is how you, and this one we can also call it as tan. So this is how you got this opposite by adjacent, and this formula we can use for finding this. So now we will look at our question which says that tan a you have to find. So we will write it as sin a by cos a. We saw that cos a is nothing but root 1 minus sine square a. So we will write it as sin a by root 1 minus sine square a. So in this way sin a is there, and we found cos a and sec also. This is how you should do this type of question, that in terms of, that means, for example, in this question we saw the tan a, so it means we have to represent tan a in terms of sin a and sin a only, and cos a also we represented as 1 minus sine square a in terms of sin only is there, 1 no problem, and sec also we represented like that, 1 by 1 root 1 minus sine square a. So in terms means itself says that it should be sin a only, or if it is written in terms of cos a, then it should be only in terms of only cos a should be there. So like that it keeps on changing according to the question. Now example number 13. This is actually a proof question. So we will see how to solve the proof question. Ck equal to, and one more thing I will say, that one important thing is that any proof question you have to convert them into sin a and cos a if you cannot find the answer. That is one of the biggest tricks that I want to give you, and other than nothing is there. So we will directly move on to the proof question. First one is Ck, example number 13. Ck 1 minus sin a, Ck plus write it clearly, Ck plus tan a. So now equal to 1 decay. Now we will solve LHS and we will get answers 1, then we can prove the LHS equal to RHS. Now we will solve LHS. CK we can write it as 1 by cos A. As I said, we have to change into sin A and cos A, and 1 minus sin A, let it be there, and CK plus tan A we can change into 1 by cos A plus tan A, as I said, sin A by cos A. So 1 by cos A, 1 minus sin A, and if you take LCM for this, no need to take LCM, just add it because denominator is same, that is cos A and cos A. So it will become 1 plus by cos A. Now this cos A you can multiply with this cos A, so it will become 1 by cos square A, and this will be 1 minus sin A, and this will be 1 plus sin A. As you know the identity that A minus B, if you are watching from the starting of the trigonometry chapters, my videos, you will be able to answer this, that we have to use identity for this type of questions, because A minus B into A plus B nothing but A square minus B square, as I had already said this identity to you. So now we will see how to solve this based on this in this question. So 1 by cos square A, and 1 minus sin A into 1 plus sin A is nothing but 1 square minus sin square A. One square minus sin square A, that is 1 by cos square equal into 1 minus sin square A, and we know that 1 minus sin square A is nothing but cos square A. So we will write it as 1 by cos square A into cos square A will give you 1, that is 1 into 1 is nothing but 1 only. So that we can say that RHS or LHS equal to RHS, or RHS equal to LHS. So we proved it, or we can write hence proved. I write HP, but in exam you can write hence proved. Now we will look at the next question, which says that prove that cot A minus cos A by cot A plus cos A equal to cosec A minus 1 by cosec A plus 1. In this we have to solve both LHS and RHS. So we'll write down the question. It says that cot A minus cos A by cot A plus cos A gives us cosec A minus 1 by plus 1. Now we will solve LHS. Cot A, as we said, that we have to always change into sin A and cos A. So we will change cot A into sin A and cos A. If it will be cot A is 1 by tan A, so it will be tan A sin by cos A. So it will, cot A will be cos A by sin A. Cos A cos A. Now on solving this by using LCM method, multiply this by sin A by 1 into sin A, and this also into sin A, and the bottom part 1 into sin A. Now cos A minus by sin A. Sin A cancel. Sin A cancel. So it will become cos A minus cos A sin A by cos A plus cos A sin A. Now you can see the cos A and cos A, cos A and cos A is common. So if we can take it out, so it will become cos A 1 plus 1 minus sin A (1 minus sin A by 1 plus sin A). Now we will do the RHS side, that is the side which is in our right hand side. So it says that cosec A minus 1 cosec A plus 1. Cosec A we can write it as 1 by sin A. One minus sin A one plus this after taking the LCM. So now we can see that here we got 1 on substituting and doing RHS, we got 1 plus 1 minus sin A by 1 plus sin A, and here also we can see that 1 minus sin A by 1 plus sin A. That means it says that this both are equal. So RHS equal to LHS. So hence proved. Now we'll move on to the 15th one. It says that sin theta minus cos theta plus 1 by plus cos theta plus cos theta minus 1, and we have to put the RHS. So now I will write only the LHS because I don't have space over here. So LHS. So in any question, for example, here we saw that 1 and here we saw that minus 1. Above it should be always minus 1 for some type of questions. For example, it should be sine theta minus 1 plus cos theta. Then we can use that minus 1 and and expand it into identity and put them in the formula and use them. For example, to change this into minus 1, we have to divide them by what? Cos theta, that is the middle value. So it will become sine theta by cos theta is nothing but tan theta, and minus 1 plus by cos theta is nothing but sec theta. By sec theta. So in my problem solving next onwards, I will not be able to use I will not be able to write full denominator. I will just write dr, so that we get time to do more and more questions. So tan theta plus sec theta minus 1 by dr. Tan theta plus sec theta. Now 1 we can we saw that 1 plus tan square theta equal to sec square theta. Identity 1 plus tan square theta equal to sec square theta. So 1 equal to sec square theta minus tan square theta. In the same way, instead of minus 1 we will put this. If it is minus 1, it will become tan square theta minus sec square theta. So by this, using this knowledge, we will put this in the question. That is tan square theta minus sec square theta. So it will come as tan theta plus sec theta plus tan square theta minus sec square theta by denominator. Now tan a square minus b square, we can split into a plus b into a minus b. That I am talking about this thing. So it will be tan theta plus sec theta plus tan theta minus sec theta plus tan square a plus b into a square minus b square equal to a plus b into just a plus b into a minus minus sec theta. It is denominator. Now plus sec theta minus sec theta cancel, and now tan theta plus sec theta. Let me do this in another page. This just remember this minus 1. So it will be tan theta plus sec theta, and this one, it is not, we previously I solved it as plus or minus. It is wrong. It is not plus or minus, rather it is into. So it will be bracket tan square theta minus sec square theta by dr. So it will come as tan theta, this I said a square minus b square, so it will be a plus b into a minus b. So tan theta plus sec theta plus sec theta. Now we can see that this tan theta plus sec theta and this tan theta plus sec theta are common. So we will take this common by denominator. So tan theta bracket. So it will become 1 and what is left? Tan we need to put a plus sign. So it will become 1 into 1 plus tan theta sec theta. By now we will open see the denominator. What is the denominator? It is nothing but well, let us see, tan theta plus 1 minus sec theta. So it will be tan theta plus 1 minus sec theta. We can cancel this. So what is left is tan theta plus sec theta. So we got this, and it is written 1 by sec theta minus tan theta. Now we will solve the RHS side. It says that 1 by sec theta minus tan theta, we can rationalize by multiplying sec theta plus tan theta by sec theta plus tan theta. Now it will become sec theta plus tan theta by a plus b. A minus b into a plus b is nothing but a square minus b square. So sec square theta minus tan square theta. Now we know that 1 plus tan square theta equal to sec square theta. So 1 equal to sec square theta minus tan square theta. So by this and this, if we compare, it will become 1. So it is sec down 1 means no value, so it will become sec theta plus tan theta. So if you compare LHS and RHS, sec theta plus tan theta and sec theta plus tan theta, we can say that LHS equal to RHS. Therefore, it is equal. Hence, proved. HP. So our next is exercise number 8.4, which says that first question is express the trigonometric ratio sin A, sec, tan A in terms of cot A. So we saw in the previous thing it is sin A. So now we have to express it in terms of cot A. So first we will use the identity of cot A and find what is necessary things. Now first we can see that it is very simple to find tan A from cot A, because in terms of cot A, because tan is nothing but tan A in terms of cot A. In terms, so it will become 1 by cot A. This we already learned that it is just the reciprocal. So you can directly write that tan A equal to 1 by cot A. Tan A equal to 1 by cot A. Now our second for the second thing, we will use our identity, that is 1 plus cot square A equal to cosec square A. 1 plus cot square A equal to cosec square A, and cots, let this be same. Now we have to find sin A. We can easily find from this, because cosec square A is nothing but 1 by sin square A. As I said, cosec A equal to 1 by sin A, so cosec square A equal to 1 by sin square A equal to 1 plus cot square A. So sin square A is nothing but 1 by 1 plus cot square A. So sin A will be root 1 plus cot square A. So we got sin A, tan A. Now our tan A we got, sin A we got. So the third is ck. So ck we can write it as 1 by cos A. Now we have to find relationship between cos A and cot A. Then we can easily say that. Now we know that cot is nothing but cos A by sin A. This one we have already learned. And sin A we know that it is sin A we got it as 1 by root 1 plus cot square A. So we'll expand this, then we understand. Read it clearly. Cos A root, and one more thing is there, it is 1 by root 1 plus cot square A. Now we will see this one. If you bring it up, it will be okay. Then otherwise you bring rather than bring here, bring it over here, so it will become cot A into so it will become it will come over here as 1 by root 1 plus cot square A. So it will be cot A by root 1 plus cot square A equal to cos A. So now we found the third part also, that is cos A. So our next question is second one. And now before coming to the second question, we can see that in the first question it is not asked cos A, it is asked ck. So we saw that ck is nothing but 1 by cos A, so it will become root 1 plus cot square A by cot A. So this is the required answer. So we can write this also, but after that we have to write this step. This is necessary. So now we'll move on to the second one. It says that write all the trigonometric ratios in terms of ck. So this is same part as we did so many questions based on this. So we'll move on to the third question, which third question, because we are running out of time. So it says that third question says that sin square 63 degree plus sin square 27 degree. We'll write it down. (60) 3 degree plus sin square 27 degree by cos square 17 degree plus cos square 73 degree. Now we know that sin square plus cos square equal to 1, and this is a combination of identities and trigonometric ratios of complementary angle. Now we will see how it is related. Sin square 63 we can write it as sin square 63 equal to cos square 90 minus 63. So it will be cos square 27 degree. So by this sin 63 and substituting as cos square 27 degree, it will become cos square 27 degree plus sin square 27 degree, and in the same way as the bottom thing as cos, instead of cos square 17 we will change into sin squared, so it will become sin square 73. So sin square 73 degree plus cos square 73 degree. Now cos square A plus sin square A is nothing but 1. In the same way, cos square 27 plus sin square 27 is equal to 1. So 1 by, and sin square 73 plus cos square 73 is also 1. That means 1. So equal to 1. So we found the value as 1. So our next question is sin 25 degree, cos 65 degree, and plus cos 25 degree, and sin 65 degree. Now we can the same as the first part, we have to use both the things, that is the trigonometric identities and the trigonometric ratios of complementary angles. We can find that sin 25 is nothing but cos 65. Let me show you how. Sin 25 equal to cos 90 minus 25, that is cos 65. So we will substitute this in the case of cos 65. We as cos 65, so it will become cos 65 into cos 65 plus, instead of cos 25 we will write it as okay, instead of instead of cos 25 will change it as sin 65. So it will become sin 65 degree into sin 65 degree. So cos into cos is nothing but cos square 65 degree, and degree we can't square because it is not a rule of the, only cos and cos we can square. So cos square 65 degree plus, in the same way sin square, sin into sin equal to sin square 65 degree. Now we can see the 65 same, and cos square sin square, we know that identity that cos square plus sin square is nothing but 1. So cos square 65 degree plus sin square 65 degree is nothing but 1. So in this way we found the answer. So our next question is multiple choice question, that is choose the correct option, justify your choice. So the first one is 9 sec square a minus 9 tan square a. 9 sec square a minus 9 tan square a equal to how much? So 9 we will keep it as in the common side, and sec square we will bring it inside, so it will be sec square a minus tan square a, and if you use the identity you will get that 1 plus tan square a equal to sec square a. 1 plus tan square a equal to sec square a. 1 plus tan square a equal to sec square a. So 1 equal to sec square a minus tan square a. So we found 1 as the answer. So in this way if you do it, means we will get 1 as the answer for this. So we can see the sec square a minus tan square is same as sec square a minus tan square a over here. So we can say that 9 into 1 is nothing but 9. That means option number B, we say that 9. Now we will move on to the next one, second part. 1 plus tan theta plus sec theta bracket 1 plus cot theta minus cosec theta. Now we will change this tan theta and sec theta, cot theta and cosec theta into sin and cos, in terms of sin and cos. So it will become 1 plus sin theta by cos theta plus 1 by cos theta. And if you have any other simpler method, you please write it in the comment, so that in my next video I can show you to the other people who are watching this video. So it will be 1 plus the other one bracket, it will be 1 plus cos theta by sin theta minus 1 by sin theta. Now while taking LCM of first and second, we will get that cos theta plus sin theta plus 1 by cos theta bracket, and the other one is sin theta plus cos theta minus 1 by sin theta, and now sin cos theta and sin theta we can take it out, so it will become 1 by sin theta cos theta, and the bracket it will become 1 plus sin theta cos theta, 1 plus sin theta plus cos theta, and bracket 1 sin cos theta plus sin theta minus 1. And so now it will be, now we will leave like this, and now we will solve this and this and this. So on opening the bracket, it will become 1 into cos theta, it is nothing but cos theta plus sin theta minus 1, and this sin theta into cos theta is nothing but plus sin theta cos theta, and sin theta into plus it will become plus sin square theta minus sin theta plus cos square theta, then plus sin theta cos theta minus cos theta. Now plus cos theta minus cos theta cancel, plus sin theta minus sin theta cancel, and now minus 1 is there, and sin square theta plus cos square theta is nothing but 1, so minus 1 plus 1 is nothing but 0, so that also cancel. Now remaining is 2 sin theta cos theta, and now we will if we look at the top thing, we have left this, so by that if we solve means it will become 1 by sin theta cos theta into 2 sin theta cos theta. Sin theta cos theta cancel, so 2 is the answer. So option number very neatly. So it is option number C. So we will move on to the next one. It says that ck plus tan a. Third one. ck plus tan a and into 1 minus sin a. Now we are to find. So in the same, as I said, in everything, if you do not get the proper steps, just change into sin and cos and find. Sin and cos, it will be normally easy, because as you practice, you will mostly be doing the problems based on sin and cos, so you will get most basic idea about that. So ck, it will become 1 by cos a plus sin a by cos a into 1 minus sin a. And now 1 plus 1 by cos a, we can take it as common. It will become 1 plus sin a 1 minus sine a. And now 1 plus sine a, that is a 1 plus sine a into 1 minus sine a is nothing but 1 square minus sine square a. So we can write it as 1 into 1 is same as 1. So we can write it as 1 minus sine square a 1 by cos a. 1 by cos a into 1 minus sine square is nothing but cos square a. Cancelling cos a. So it is option number D. Now we will look at the fourth, which says that 1 plus tan square a. 1 plus tan square a by 1 plus cot square a is how much? So 1 plus tan square a is nothing but 6 square a. Using the identity we found that. So 6 square a by 1 plus cot square a is nothing but cosec square a. And 6 square a we can change it into change 6 square a into 1 by cos square a. And cosec square a we can change into 1 by sine square a. So if we bring this up, it will be 1 by cosec square a into sine square. Why this? Okay, sine square by 1. So it will become sine 1 into sine square is nothing but sine square a by it's not a, it's cos square a. So it will become cos square a. So we can write it in another words, sine a by cos a the whole square. So it will be tan square a. As you know that sine a by cos a is nothing but tan a. So tan into tan a is tan square a is tan a, the whole square is nothing but tan square a. So option number D. So we have come to the end of this exercise 8.4. Only the fifth question is left. Fifth question I will be creating in my next video, as it is a very long exercise which consists of 10 parts, that is all the identities, and there are so much tricks in that. So with this I will be I have come to the end of the video, and if you hope you like this video. If you like this, please subscribe it, and if you want to share, please share it. So we will meet in our next video. Thank you.